Newton-Raphson Method. Newton-Raphson is named after Isaac Newton and Joseph Raphson. This method is a popular iterative method to solve or to find for the root of a polynomial function. Why polynomial? Because the Newton-Raphson is used if function is differentiable. The method for Newton-Raphson, or the formula for Newton-Raphson, is so simple because x sub 2 is just equals to x sub 1 minus f of x over f prime of x. That is why we have, or we need a function that is differentiable, because it is to complete the formula of the Newton-Raphson. Let us now have the algorithm for the Newton-Raphson method. Newton-Raphson algorithm. The first step for solving a function to find its root by using a Newton-Raphson is to check if the given function is differentiable. If not, Newton-Raphson method can't be used. Number 2. Find derivative of the function. Just have to get the derivative of the given function. Then proceed to step number 3, which is to use the Newton-Raphson formula to get x sub 2. Newton-Raphson formula, let us recall, x sub 2 equals to x sub 1 minus f of x over f prime of x, where the f prime of x came from the second step, which is to derive the given function. The fourth step is to repeat the process for x sub 3 and x sub 4 and so on, till the actual root of the function is obtained. You can check if you have the function or the solution to the function if the error is 0%. Let us have the example for Newton-Raphson. Let us now have an example for the Newton-Raphson method. Let's find the root of the function by using the Newton-Raphson method. Given the function f of x is equals to x cubed minus 17x squared minus 2x. The first step is to check if the function is differentiable. Is the given function differentiable? Yes. So let us find the derivative of this function. This will be 3x squared minus 34x minus 2. The next step for the Newton-Raphson method is to have an initial guess, x sub 1. Let's think of an initial guess. Let's make our initial guess 1. Negative 1. Then, use Newton-Raphson method formula to obtain x sub 2. Then we'll get negative 1 minus, substitute this negative 1 to the function, we'll get negative 16 over, substituting this value to the f prime, we'll get 35, and our x2 final value is negative 0.54285, and so on. And to check if we have already found the root, let us have a new value of x sub 3. Using x sub 2, negative 0.5428 minus, substituting this function for x sub 3, our final value is negative 0.3. Solve it in your own. 0.7345613 and check if you got the same answer. Then checking if we have found the root, let us have an error approximation. Let's get the absolute value, the present value negative 0.3 minus the previous value negative, or let's make this positive 0.5 over the present value negative 0.3 times 100 the error would be negative 76.60%. So we have big value of error. That's why we need to have an additional iterative to refine the roots of the function. That's all for the Newton-Raphson method. Thank you.